Hello everyone, Tim Robinson from the Blue Scope Media team. We've got a very special opportunity here today in the number 6 blast furnace. We're going to head inside the 62 stove. Clint Mackenzie is going to give us an inside tour. It's the only time we get to do it before it all gets fired back up. So Clint, we're standing on top of what we call the checker chamber. What's the job of the checker chamber?
So what the purpose of the stove is to get the hot air for the blast furnace for the blast. So what happens is we have a combustion chamber and a burner where we mix gas and air to burn off to create the hot air. It comes up the combustion chamber, goes down through these checker bricks and this checker chamber. These checker bricks soak up all that heat. It goes down through and out our waste gas, so that's the stove is on a gassing cycle. When we want the stove to go to a blast cycle, the operation is reversed, so we then put cold blast in the bottom of the checker chamber up through these checkers to get all that heat. Goes down the combustion chamber and out the hot blast valve into the hot blast main, which takes us over to the blast furnace to give us the blast for the blast furnace. During operation, we were getting hot spots on the actual shell in this knuckle joint. So this joint is where the shape of the stove changes from the shaft to the dome. So during operation we used to get hot spots. We used to have to weld sockets on the outside, pump grout in to protect the shell. So part of this investigation work is to remove these checkers, remove our refractory brickwork back to the shell to expose this area. One, to check the condition of that weld and the shell, make sure the shell's in good condition, but also find where the blast has been tracking in, causing these hot spots.
When we're looking outside your dome and your round shape, but this side turns into sort of more like an eye shape. Is there any sort of reason for that?
Yeah, correct. So this is if you can stick your camera down there, that's the combustion chamber. You may be able to see all the way down there to the burner. The burner's at the base of the stove there. It's a designed refractory burner with air and gas mixture that will ignite with the heat of the stove. The gas for the burner is we actually use the blast furnace gas. So as the hot blast goes through to the furnace, through the process we generate blast furnace gas. We actually use that blast furnace gas back in our burner.
Hole there, what's that?
So that's a pyrometer. So basically there's an instrument that's bolted to a flange outside the stove that shoots in. There's like a target brick in underneath the scaffold, and that's measuring the temperature of the checker chambers and the dome when we're online.
What temperatures are we expecting?
Dome temperatures, I think, is about 1200 degrees.
How often are these sort of things checked, looked at, repaired? You might have to stop one to do repairs.
So internally, this is the only opportunity we get to come inside a stove. So once we're in operation, there's too much heat in this stove to be able to enter and do any kind of maintenance. So it's kind of like a once in a campaign opportunity to get in here and get this right.